Now that we're familiar with the concept of antidifferentiation, we can do two things. The first one is we can find the antiderivatives of functions that you are already familiar with and do direct integration just by looking at the table of derivatives that we have. For example, we know that the antiderivative of cosine is going to be sine because the derivative of sine is the derivative of cosine. And we know that the antiderivative of sine is going to be minus cosine because the derivative of cosine was minus sine. And similarly with tangent. So the derivative of tangent was secant squared, meaning the antiderivative of secant squared is going to be tangent x. Of course, we cannot forget that each of these functions is going to have a plus c, where c is a constant value and it's a real number. In your formula booklet, you are going to find a few more integrals that you should feel free to use, and they are related to the derivatives that you are already familiar with. Now, the second thing that we can do is to introduce a few rules. And I want to introduce the first rule here, and that's going to be the power rule. And also, I want to introduce the rule for the sum of a function. Let's consider these three functions, x squared, x power 3, and let's try to find the antiderivative of each of them. Now, I'm going to start with x. Which function has a derivative of x? Well, I know that the derivative of x squared leads to 2x. But in the f of x that was given, this 2 is not present, which means that when I did the derivative, it got cancelled. So it's fair to assume that the original functions should be multiplying by 1 over 2, so that when we do the derivative, 2 divided by 2 cancels, and I get simply x. So for the function x, I know that the antiderivative is going to be 1/2 x squared. Now when I do the antiderivative of x squared, I'm going to have a similar reasoning. The function that gives me x squared in the derivative is going to be x power 3. But the derivative of x power 3 is 3x power 2, not just x power 2, meaning these 3 must have been cancelled in the original function, which means I should have a 1/3 in the original function so that when I do the derivative, these 3 cancels and I simply get x squared. So with that reasoning, my antiderivative is going to be 1 over 3 x power 3 plus c. Now we have x power 3. Similar reasoning. We are going to say which function had a derivative of x power 3. Well, that was x power 4. But I know that the derivative of x power 4 is 4x power 3, which means this 4 must have been cancelled somehow. So I'm going to divide the original function by 4 so that when I do the derivative, these 2 cancel and I get x power 3. Now, the antiderivative of x power 3 is going to be 1/4 x power 4. Now, look at this. Can we figure out a pattern for a general function f of x that is going to have the form f of x equals x power n? So look at what's happening. The antiderivative of x power 2 was 1 degree higher, so it became x power 3, and that same 3 appears dividing. The same thing is happening in the antiderivative of x. The antiderivative of x is 1 degree higher, and that same value is dividing. X power 3, the antiderivative was x power 4, and that same value was dividing. So it looks like the pattern is that if f of x is x power n, its antiderivative f of x is going to be x power n plus 1, 1 degree higher, divided by the exponent, n plus 1. And of course, we need to add plus c because this is antidifferentiation. Let's use this formula in an example. Find the antiderivative of f of x equals to x to the power of 2/3. So if we wanted to find the antiderivative, what we need to do is take x, add 1 to the exponent, 2/3 plus 1, and then divide by the new exponent, 2/3 plus 1, and plus c. So that is going to be x to the power of 5/3 divided by 5/3 plus c, and that is 3/5 the cubic root of x power 5 plus c. Next example is find the antiderivative of the function f of x equals x squared plus 3x minus 1. Now this is a polynomial that has 3 terms, and we know that this rule is just for one term. So what we're going to do is, because each of these terms are the result of a derivative, then we can find the antiderivative of each of these terms separately. What that means is, in order to find the antiderivative of the function f, we have to integrate the whole of the function x squared plus 3x minus 1 with respect to x, which means we are going to assess the antiderivative for each of the terms in the polynomial. So this is going to be the antiderivative of x squared plus the antiderivative of 3x minus the antiderivative of 1. So now we can use the power rule for each of these integrals. Now the antiderivative of x power 2 using the power rule is going to be x power 3 over 3 plus, now the antiderivative of 3x is going to be 3x power 2 over 2. So we're adding 1 to the exponent always and dividing by the new exponent. Minus, and 1 is x to the power of 0. So that means the integral is going to be 1 x to the power of 1 and divided by 1. And finally, plus c. There is no need for you to write multiple constants of integration. When you have multiple terms, then all you have to do is integrate each of the terms and then add at the end one unique integration constant. One property that we can note that we used in this problem is then going to be that the integral of a sum of two different functions, for example f plus g, is the same as the sum of the individual integrals. So this, you can use it anytime you have a function that is made of multiple terms. You can always separate the integral by integrating each of the terms. One more example, find the integral of the function root x plus x with respect to x. So we can use the property that we were just talking about to separate this integral into two different integrals. So we're going to say the square root of x plus x is going to be equal to the integral of root x with respect to x plus the integral of x with respect to x. Now, root of x, I don't know the integral of that. I don't know the antiderivative of the square root of x, but I do know the antiderivative of x to the power of a half. So I'm going to convert it into x to the power of a half before integrating. And now I'm going to use the power rule to calculate each of these antiderivatives. So the antiderivative of x to the power of 1/2 is going to be x to the power of 1/2 plus 1 divided by 1/2 plus 1 plus the antiderivative of x power 1 is x to the power of 1 plus 1 divided by 1 plus 1 and everything plus c. Then this is equal to x to the power of 3 halves divided by 3 halves plus x to the power of 2 divided by 2 plus c. So my final answer for this integral is going to be 2/3 x to the power of 3 in a square root plus x squared over 2 plus c.